Translation is another type of transformation, but this time it's shifting a graph horizontally and or vertically. It moves the graph left, right, up, or down, but does not change the size, shape, or orientation. Okay, so we talked about how vertical translations, you have a plus or minus k value on the end, okay? Whereas horizontal translation is going to be inside the parentheses. So if it's outside parentheses, vertical. It's exactly what you think, okay? If it's horizontal, you're going to think inside parentheses are absolute value bars, and it's almost opposite of what you think. Remember, horizontal stuff is weird, right? Because x plus h is actually to the left, where x minus h is to the right. It's just kind of strange. Okay, just a quick review. If we see a transformation that is outside of the absolute value bars, is it going to be horizontal or vertical transformation? That's going to be vertical, right? And it's going to change the y values. That little triangle means delta, so it means change the y. Okay, inside of absolute value, is that going to be horizontal or vertical? Anything inside is going to be horizontal. Does horizontal movement change the x values or the y values? Think of your horizontal axis. That's going to change the x values. Okay, so we're just going to use that as a rule of thumb. For part A, in example 3, let's start by graphing the parent function. I know to graph a V-shape because of the absolute value bars. Okay, we should see 1, 1, 2, 2, 3, 3, negative 1, 1, negative 2, 2, negative 3, 3. Okay, all of these parent function key points, it's good to just memorize them so you can fill this out quickly. Okay. The absolute value makes all of the y outputs positive. And what is the plus 2 going to do to transform our parent function? Is it outside the absolute value or inside the absolute value? It's outside, so I know it's vertical. Okay, let's just think about where this is. It's just right out back, right? What's the plus or minus k do? That's your vertical translation. So if it's plus, it would just be up, and if it's minus, then it's going to be down. Remember, vertical stuff is exactly what you think. Okay, let's go back down here. So I'm going to say that this is a vertical translation up to. Okay, and what do I do for vertical translations? What do you think I do to move something up? Like if I want every one of these points to move up to, what am I going to have to do to my y values if I want them to move up? Add 2. You're right. Okay, so 2 plus 2 is 4, 1 plus 2 is 3, 0 plus 2 is 2, 1 plus 2 is 3, and 2 plus 2 is 4. Okay, and it should make it look like my graph moved up 2. So I'm going to plot the point negative 2, 4. I'm going to plot the point negative 1, 3. I'm going to plot the point 0, 2. I'm going to plot the point 1, 3. And I'm going to plot the point 2, 4. Now what does that look like? Doesn't that look like everything just shifted up 2 units? Exactly. Okay, what about this guy? Inside or outside? It's inside absolute value. So is that going to be horizontal or vertical? Remember, inside is horizontal. So we're going to be changing our x values. Okay, so inside, I'm going to say that this is a horizontal translation. Okay, and it's almost opposite of what you think, right? Let's go all the way back here. Remember, this is the horizontal part, the x plus h or x minus h inside the absolute value. So it's this part right here. Remember, left occurred when we saw things like x plus 3, where right occurred when we saw things like x minus 2. Okay, so it's weird. It's almost opposite of what you think. So this is going to end up being a translation to the right too. Let's go ahead and start with our parent points. Okay, you can see my x column moved a bit. Okay, my parent function takes the absolute value of all of those x inputs to get the y outputs. We know that it looks like a V shape, right? And what am I going to change if it's horizontal? Does x or y change? Well, x is going to change. How is x going to change if you want to move something to the right? Like if I want to move this to the right, take 0.11 and move that to the right, and take this point and move it to the right, what am I going to have to do with all the x values to shift something to the right? I'm going to have to add 2 to all the x values. Notice how weird that is, right? It looks like x minus 2 in the absolute value bars, and it's almost opposite of what you think. You have to plus 2 in the table. That's just weird, okay? Negative 2 plus 2 would be 0. That's gone. Negative 1 plus 2 would end up being 1. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. Okay, so I should have the point 0, 2. I should have the point 1, 1. I should have the point 2, 0. I should have the point 3, 1. And I should have the point 4, 2. Okay, doesn't it look like I just picked up that red graph and shifted it to the right 2 units, and then I got the blue graph? That's what we want. All right, what about this last one down here? What transformations are we seeing? I have inside the absolute value, and then I have an out back part. So if I think back to this, what I'm using this time around is the part inside and the part out back. Okay, so what is going to happen to that graph? Remember, horizontal is inside and it's opposite of what you think. Vertical is outside absolute value bars and it's exactly what you think. So this transformation is going to be a horizontal translation, left 1, and a vertical translation, down 3. Okay, so I'm going to take my parent points, right, and transform those. So horizontal, let's start with that. What does that change, x or y? That changes the x. Remember, it's opposite of what you think. So instead of having the plus 1 there, it's actually going to be minus 1 if I'm moving something to the left. Right? And for vertical translation, that's exactly what you think. Because it says vertical, what's going to change, x or y? My y values are going to change. So I'm going to be taking all of these y values and doing what to them? Moving them down 3 or minus 3. Okay, so let me plot my parent function. This is my parent function. Okay, and I'm going to graph the new one in purple. So we'll graph the new function, this guy, in purple here in a second. Let's go ahead and take negative 2 and subtract 1. We're going to get negative 3. Negative 1 minus 1 would end up with negative 2. 0 minus 1 is negative 1. 1 minus 1 is 0. And 2 minus 1 is 1. Okay, then we've changed the y values as well. 2 minus 3 is negative 1. 1 minus 3 is negative 2. 0 minus 3 is negative 3. 1 minus 3 is negative 2. And 2 minus 3 is negative 1. Okay, so those are our new points. We have negative 3, negative 1. Like I said, I'll do this in purple. We have negative 2, negative 2. We have negative 1, negative 3. We have 0, negative 2. And we have 1, negative 1. Doesn't it look like I took my origin and I moved it to the left and then down? Doesn't it look like we moved the origin left and down? Really, you should be able to take any point on the original function and move it left 1 and down 3, and you should end up with a point on the new graph. That's how you know you did it correctly.